So how do you go about building an algorithm? How do you teach a computer that this thing is called a microcalcification and it's bad?
Sure. So this is where the deep learning part becomes interesting. It used to be the case that we would work with the radiologists and understand what is it that they're looking for to describe these lesions. For instance, calcifications are small and bright. You have these spiculated lesions that have spicule-like things flowing out of them, and so that's what they would use to identify. And then we would build features. So we would describe these things mathematically and write algorithms that describe, texture and morphology and geometry of these structures. And then we would build simple classifiers to distinguish between these cancers and non-cancer false positives, what we call them. With deep learning, we just have to feed a lot of examples. So the features are learned by the optimization process directly. So it's the features and the classifiers are optimized jointly, and so we provide
What?
examples.
Pardon me
Yes,
for
yes,
interrupting. What is
yeah.
a feature and what is a classifier? Because it
Oh,
sounds like
sure,
those terms are important.
sure, yes. So a feature is a numeric value that describes something about what we're looking for.
Okay.
So, for example, a feature could measure how round a structure is or how bright it is, and
Mm-hmm.
convert that into numeric value. Right? The more
Okay.
round it is, the more it's closer to one. The less round it is, the more closer it is to zero. The brighter it is, the more closer it is to one. The less bright, more closer it is to zero. And so these are all kind of features that describe the lesion. Okay,
Okay.
and so you have features that can describe texture, that can describe geometry or shape, that can describe intensities. And so you think about all of these, design them and put them in numbers. Okay,
Mm-hmm.
and then you have these set or this vector of numbers for cancers and for things that aren't cancers. And you when you design these features, you want to design it so that the yes. So once you have these features, the next thing to do is to use a classifier to distinguish between the cancers and the non-cancers. So for all our candidates, we have features, a whole bunch of features, and then the classifier helps us to distinguish between those that are cancer and those that are not. And so
Okay.
it learned kind of a boundary between what's cancer and what's not. And that's what we use to output a specific finding that we think is cancerous. Does that help?